All right, so we have an airplane landing on a runway, and we want to make sure it's got enough room to get to the speed it needs to get, to the final velocity it needs to get to, and we want to know, what's the question now? Let's just draw the picture first. All right, so we got a runway. All right, we got some plane here. All right, here's our plane. And just as it touches down, it has an initial, so here's where it starts, x naught, and then it goes out here to some final distance that we know. Is that correct? We know the final distance, we know the total displacement, right? So, does it tell us as a displacement? Yeah, it does. All right, and then what's our initial velocity? 69 meters per second, okay? And what's our final velocity? Not 0, no gifts this time, darn them. What is it?
It's 6.1 meters per second.
6.1 meters per second at the end. So it slows from 69 to 6.1 meters per second over some displacement, delta x. And what do we ask for? The average acceleration, we're going to assume uniform acceleration. So average is the same as instantaneous, right? So average acceleration as we do this. And so let's write down first thing. So here's D, doofus, number 25. Our first step is D, the diagram. Now, does it have to be artistic? You can just use a dot for the plane. I just like to draw planes. All right. So the second part's a U. All right. What's the unknown we're looking for? We just said it. We're looking for acceleration, right? We don't have to care if it's average or instantaneous. We're assuming it's uniform. But it's good to recognize that they are different. So that's something we don't know. So now looking up back at our diagram, we can say the things we do know. V naught is equal to 69 meters per second. V final is equal to 6.1 meters per second. And delta x I did not write up there as a value. What was it? 750 what?
Meters.
Sir, 750 meters. All right, so now let's take a look. That's the U part. Now we need to select the correct formula. F is for formula. We want to select the correct relationship. See how easy it is when you just look for what's not there? So it's pretty clear there's no time here. We use the timeless or eternal equation. And coming down here, we'll just write it in its original form. V squared is equal to V naught squared plus 2a delta x. And we're solving for what? Solving for a. You can refer to your chart, or once you get practiced, you'll remember a is equal to v squared minus v naught squared over 2 delta x. So now, here's where the tricky part is. What's our final velocity? It is less, isn't it? So it's 6.1. So acceleration is going to be equal to 6.1 meters per second squared minus 69 meters per second squared divided by 2 times 750 meters. Here's the solution part, right? We've rearranged. So this is our S of doofus. DUF. Oh yeah, here we go. This was algebra. All right, so here we are. Now what we got to do is plug stuff into a calculator. But before we plug the numbers into a calculator, what do you say we take a look at this dimensionally and make sure that we're going to be squared away? Get it? Squared away? All right. So what we got here? We're going to have meters squared per second squared on the top. All right. And on the bottom, we're going to have meters. So what's going to happen algebraically? We get meters per second squared. We're looking for an acceleration right here. So that's consistent with what we want. All right, so now we just got to do some number stuff. Now, before we crunch these numbers, I want you to look at this. Bless you. I want you to use math to guide your thinking. This is smaller than this. So when we square this and we square this, what's going to happen to the numerator? It's going to be negative. So we're going to divide by a positive number. That means we're going to get a negative acceleration. Is that consistent with what we would expect? Yeah, because what are we trying to do? We have a positive initial velocity, and we're trying to what? Slow down, right? So we want those acceleration and velocity vectors to be anti-parallel. You can just bear with me for 1 second, and we'll do the number crunching. Acceleration is equal to what? 6.1 squared. 36, 30, come on, calculate that. 37.2?
1.
Yeah, it can't be a 2. 37.1 meters squared per second squared minus 69 squared, a little less than 4,900. What? 4761 meters squared per second squared divided by, this one's easy, 1,500 meters. So don't worry about what's in the numerator and what's in the denominator. Can you just give me a final crunch out there?
3.15 meters per second.
Sorry, Kate, one more time.
Negative 3.15 meters per second.
Meters per second squared. Now, did we just throw that on at the end? No. We got this right here. We did the correct unit thing, dimensional. All right, and we are done. Call it.